Okay, here I'm trying to explain double slit interference of light. Okay, so here we're going to use red laser, red light. The wavelength of the light is 650 nanometers. This is a monochromatic ray. That means it has only single wavelength. Now if you get a visible light, that is the mixture of different colors. So it has all the colors with different wavelengths starting around 400 nanometers to go all the way up to 700 nanometers. Here I'm going to use monochromatic light, which is single wavelength. The wavelength is 650 nanometers. So in that range, what we have is red. So I have a red laser. You can see I have a red laser. Now I'm going to send this laser beam through a double slit. Okay, let's see what is this double slit. You can see here two very fine slits. The width of the slit is 0.08 millimeters, and the separation between these two slits is 0.5 millimeters. So if you want to go to the the micrometer range, the width of the slit is 80 micrometers. The separation between the slit is 500 micrometers. So we're going to send our laser beam through these two slits and see what kind of image we will get in the screen. So we have a screen here. Now laser beam and nothing in between laser beam and the screen. So you have the laser beam on the screen. Now I'm going to put the slit, double slit, in between laser beam and the screen. I'm going to keep the separation between the slits, two slits, and the screen 1 meter. So you can see this 10 here and 110 here, so that's 1 meter. And now I'm going to send this laser beam through those double slits. You can see the laser beam, two slits, and the light is coming through that slit. So I came to the board. Now let's try to understand what we'll see in the screen. So we have our red laser. The wavelength of the red laser is 650 nanometers, nano, 10 to the minus 9 meters. So 650 nanometers. If you want to get that in micrometers, this is this divided by 1000, so 0.650 micrometers. That is the wavelength of the red laser. And we have the slits here. We have the slits, and we're going to use this double slit. So these are the double slits, slit 1, slit 2, and the separation between them. Okay, so I'm going to draw it somewhere here. Slit 1, and there's separation between the slits, and this is the second slit here, and this is called width of the slit, and that is 0.08 millimeters. Let's call it D. Let's call it A. A equals 0.08 millimeters. That's equal to, if you want to get this in micrometers, that is multiplied by 1000, 80 micrometers. And the separation between the slits, that is the length from the center of the one slit to the center of the other slit, let's call it D. D equals 0.5 millimeters. If you want to get that in micrometers, that is 500 micrometers. So you can see these are very small lengths. Now here I have the double slit. And here I have my screen. And the separation between the screen and the double slit, that's 1 meters. So I'm going to call this L. L is the length between screen and the double slit. L equals 1 meter. So this is my setup. Now, what do you think? What will you get in the screen? And so far we learned light as rays. So the light rays will go through the slits, and you have 2 slits, right? Then you should see something like this. Light is coming through that 2 slits, and you will see that 2 slits on the. If I want to see this in 3D, this is my screen, and here I should see 2 slits like this. What I'm going to see in the screen. Oh, what should I? Oh, that is what I'm expecting to see in the screen. Okay, let's go to our experimental setup and see what we're going to see.